differential equations by substituting y equals to Vx. These are the procedures to solve the differential equations. First, you need to rearrange the equation so that dy dx is on one side while q and p is on the other side. Next, make a substitution of y equals to Vx, which in accordance to the product rules, dy dx it will be equals to v plus x dv dx. Next, you need to substitute dy and dy dx, which are this and this, into the equations which you have arranged earlier on. Simplify the equations until the variables are separable. Next, you separate the variables and solve the differential equations. Lastly, you substitute v equals to y per x, which is derived from the y equals to vx here, into the original variable as integrated from the steps here. If you find this difficult to imagine, let us look at one example. The questions ask us to differentiate these differential equations. It is given that x equals to 1 and y equals to 2. Your first step now is to rearrange the equations so that dy dx is on one side while the remaining is on the other side. Next, you let y equals to Vx, which based on the product rule, after differentiations of the y equals to Vx, it will give you this. Refer from the equations which you have arranged previously. Substitute the y in the function here with Vx, and substitute the dy dx from the functions which we have derived just now. This gives you these equations, and you will need to rearrange and simplify the equations so that the variables are separated. Now you have the dx on one side and dv on the other side. Integrate both sides of the equations, you will get this. Remember to incorporate c after the integrations. From the function here, you have v. Based on the equation here, v will be equals to y per x. Therefore, you will substitute y per x into the v in the function here, which gives you this. It is given that x equals to 1 when y equals to 2. Substitute the relevant value into the equation here, and you will solve it to get c equals to 2. Go back to the original equations, substitute c equals to 2 into the functions, you will get this. Rearrange the functions, this will be the final solution. Let us try another example. You have been given an differential equation here. It is given that y equals to 4 when x is equals to 1. To solve this, first copy down the equations. Put dy dx on one side while the remaining on the other side, which will give you these functions. Let y equals to Vx. Based on the product rules, differentiations of y equals to Vx, you will get this. In the function here, you have y. Substitute y equals to Vx to replace the y in the function here. And for the dy dx here, substitute with these functions. This will give you these functions. Your next step will be rearranging and simplifying the equations. After the equation have been simplified, you will get this. Now you have v and x and dv dx. Separate the variable so that one side is dv while the other side is dx. Integrating both sides, you will get this. Remember to incorporate c at the end of the expressions. In the function here, you will see v here. The v is actually a component of y equals to vx. So you may replace v here into the function here, which will give you v equals to y per x. Substituting v equals to y per x into the equation, you get this. The boundary conditions give you that y equals to 4 when x is equals to 1. Substitute the value into the function here in order for you to find the constant c. This step shows the substitutions of y and x in the functions, and the c is obtained as 8. Refers to the function here, substitute c into the functions, you will get this. Rearrange the functions, you get this. This will be your final solutions for this example.